Hello everyone, this is grade 6, module 5, lesson 1, problem set. Now the lesson summary talks about the formula that we're going to need here to find area of a parallelogram, which is A equals BH, or area equals base times height. Now the big thing that we have to keep in mind is where the height is for the parallelogram, and it's a line segment perpendicular to the base. So we'll show that with the first two questions here, because down here in the problem set it says draw and label the height of each parallelogram. There's a couple different ways you could label this, but it has to form a 90-degree angle to the base. It has to be perpendicular. So I'm going to go from this outside vertex, and I'm going to draw a dotted line straight down. And I'm going to continue the base out. And this straight shot there is going to be my height. And I know that because it's going to create a 90-degree angle, and there's my box for my 90 degrees. So it's a straight shot from the top vertex down to the base. It has to be a straight line. So for number 2, I'm going to do the same thing. I'm going to draw a dotted line coming straight down. And then I'm going to do a dotted line coming straight out from the base. Wow, that looks so much better than that first one. And that's going to be my height, or H. And I'll actually write that one out. And again, I'll draw in my little box there to show that it's a perpendicular line because it makes a 90-degree angle. So when I'm doing my area for these, I'm using this measurement and that measurement. I'm not using these because those aren't height. That's just a measure of the side. So let's take a look down below. We have 3 through 6 here. I'll do 2 of these. I'll do 3, and then we'll glance at one of the ones down below. So again, I'm always going to start by doing my formula. And I know that area equals base times height. So now I can take a look, and I see I have 3 measurements. I'm only going to use 2. I know that this piece right there is my base. And then I'm looking for the line down from the vertex that makes a perpendicular line to the base. And that's right here, so I'm going to use 6 as my height. I don't need anything to do with the 8 right now, because that's just a measure of one of the sides. So again, I'm going to rewrite my formula, area, and now I'm going to substitute in my base and my heights with units. My base is 13 centimeters. And I'm going to put my dot for multiplication. Remember, it has to be halfway up. If it's at the bottom, it looks like a decimal point. So 13 centimeters, and my height is 6 centimeters. So now I can go through and I can calculate that out. And I'm going to show my multiplication up top here. 18, I'll carry it. 6 times 1 is 6, plus 1 is 7. So I have 78. 78 what? Well, I know I'm working with my unit of centimeters, but because I multiplied a centimeter times a centimeter, I get centimeters squared. So that's my area. Now, the same thing can be said if we go down. Let's take a look at, we'll do 6. And again, I know I'm looking for area, so I want to start off writing my formula. Area equals base times height. Because I have to make sure that I know what formula I'm identifying and using. So I'm going to look for the base, and the base is this measurement right here. Now, they put in this dotted line one to show how long of a line or how long of a segment needs to get over here to this dotted line coming straight down. We don't need that. That's just a measurement that's there for no reason in terms of area. So there's my base. Now my height, again, it's the dotted line coming down from the vertex, and it creates a 90-degree angle with the base. So that's my height. So I'm going to rewrite. My base is 4 1/3 meters. times 3 1/2 meters. So I got to go through and I got to multiply this out, and I'm going to stretch over here a little bit. And what I've found to be easiest for these types of problems is turning them into fractions greater than 1. Meaning, I'm going to take this 4 and say how many units of thirds will that make. So I'm going to show this one a little bit differently. I'm going to use a number bond at first, and then I'll show you probably the way that your teachers have shown you. I know that 1 whole is 3/3. So I know I need 4 1 wholes. So really I have 3, 6, 9, 12 thirds equals 4. And if I add in my 1/3 that's right here, I get 13 thirds. So I have 13 thirds meters. Now the way that you probably are doing this as well, because this shows that, so if I have 4 1/3, I can multiply and add and bring it around. 3 times 4 is 12, plus 1 is 13, and I'm always talking about thirds in terms of this in terms of this number, because that's the units I started with. So there's 13 thirds. Why does this work? Because I had 3 thirds right here, and I had 4 of them. So I drew that with a number bond to show you why this strategy works. So I can do the same thing with the 3 1/2, multiply, add, and again, it's because I have 3 2/2, or 2/2s. So that's 6/2 plus 1/2 equals 7/2, or 7/2. Now I can just multiply across because I have fractions. 13 times 7 gets me 91. And 3 times 2 is 6. And again, since I have a meter times a meter, it's meters squared. So my area for this is 91.6 meters squared. That's how it's drawn or written as a fraction greater than 1. But what I want to do now is I want to simplify this out and turn it back into a mixed number. So I know that a fraction is really a division problem. So 91 divided by 6. And I could go into a decimal for this, but I'm not. I'm going to take my remainder and make that remainder my numerator. And since I'm dividing by 6 here, I'm going to stay with 6. So it's 15 1/6. So my real area is 91.6 meters squared, or 15 1/6 meters squared. A lot of work for these types of problems when we get into fractions and decimals. So be sure to use an extra sheet of paper or some blank space. Let's take a look at page 2 real quick. And on page 2, I'll go over 2 of these. I'll do 7 and 9 real quick. 7 says, Brittany and Sid were both asked to draw the height of a parallelogram. Their answers are below. So Brittany drew the height right here. Sid drew the height right there. Are both Brittany and Sid correct? If not, who is correct? Explain your answer. We know the height for a parallelogram has to make a perpendicular, or has to be perpendicular to the base. So it has to make a 90-degree angle. And I can see that right here. And it has to come from one side of the parallelogram to the opposite side hitting the base. And I see that both of them do that. So, are they both correct? Yes. Both are correct. And then for my explanation here, it's going to be because both created a perpendicular line segment to the base, creating a 90-degree angle. Let's take a look down at 9 very quickly to write the equation. I'll help you with the equation, and then you can use your knowledge from Module 4 with equations and expressions to solve this. So a parallelogram has an area of 20 3/10 centimeters squared and a base of 2 5/10 centimeters. Write an equation that relates the area to the base and the height. So I know we're talking about area, so I'm going to put my formula down. And now I'm going to substitute in what they give me in this statement. They gave me the area. So instead of putting A, I'm going to put down 20 3/10 centimeters squared. That equals my base, which is 2 5/10. I see it right there. And we were not given the height. So I know that 2 5/10 centimeters times something is going to get me my 20 3/10 centimeters squared. So using your knowledge for equations and expressions, you'll go through and solve to determine the height. Hope this helps. Good luck on your problem set, and thanks for watching.